Hello, everyone. Hello, my dear students. I'm your Liu 老师. I'm very glad to have this opportunity to study with you at such a special time in this special teaching way to study pharmacological labs. And though you don't do the lab, I hope you will prepare carefully. I look forward to seeing you can imagine and to understand how to do the lab. This class is the second lab in pharmacological experiment, and we will to study to observe the assay method of FD 50%. So 50% lethal dose. At first, what's the meaning of 50% lethal dose? Ld50's definition is a dose that gives rise to the death of the 50% of subjects is called Ld50. From this curve, we can know Ld50, the mortality is 50%. In our pharmacology class, we have studied some professional terms. At first, we know this curve. We call this curve is the graded dose response relationship curve. And the graded dose response relationship can describe that in a certain range of doses, the pharmacological response is increased with the increase in those doses without evident toxic effects. Usually log concentration pharmacological effect curve is used. For example, gradually increase in contraction of given peak ileum is induced by gradually increasing the dose of histamine. However, as maximal effects rates, further increase in histamine concentration exerts no additional effect. And this curve, this log concentration pharmacological effect curve we used is graded dose response relationship curve. And we also studied all-nine response. We also call this all-nine response is contour response. All-nine response indicates that a given dose of a drug has not evoked a certain effect in the various subjects under investigation. For example, to test either presence or absence of hypnosis for sedative and hypnotics is a case in point. For another example, we can use negative or positive to explain all or none response. In graded dose response relationship curve, and we have studied some professional terms. The first one is TD. TD, threshold dose, indicates the least amount of drug required to exert therapeutic effects. And the next one is efficacy, Emax. Emax is a maximal effect, is the maximal response that can be produced by the drug. For examples, in accord with the efficacy, in accord with the maximal response, we can divide diuretics into three kinds. There are high efficacy diuretics, furosemide, and moderate efficacy diuretics, thiazides, low efficacy diuretics, spironolactones. In this curve, we have studied EC50 is the concentration of drug that produces 50% of maximal effect. Before we study Ld50, and we also should study this and review these professional terms, such as Ld50. Ld50 medium effective dose is the dose of a drug that produces 50% of maximal effect. Today, we want to observe the Ld50. Ld50 median lethal dose is a dose gives rise to the death of 50% of animals. Thus now we have known the death rate is 50%, and this dose is Ld50. Next one is Td50. Median toxic dose is a dose required to produce a particular toxic effect in 50% of LD animals. Td50, a dose that causes the toxic effect in 50% of subjects. So we call this Td50. We studied a very important conception is TI. The full name of TI is therapeutic index, and TI make equal to Ld50 divide Ed50. We use TI therapeutic index describes the safety of a drug. The greater the larger value of the therapeutic index is, the wider margin between effective dose and toxic dose is safer. However, if the LDR log dose response curve of therapeutic and toxic effects of two drugs are not parallel, certain safety factor is used for comparison. And just now we use this one, TI therapeutic index, to describe the safety of a drug. And we also know the greater the larger the ratio is, the greater the safety is. So we observe the Ld50, 50% lethal dose, similar to therapeutic index. The greater the larger the Ld50 is, the greater the safety is. So we also use Ld50 to describe the safety of a drug. Ld50 is a toxicity signal of a drug. We use Ld50 to describe the safety of a drug. For example, we have two drugs. One is A drug, the other one is B drug. Both of them they are diuretics, or both of them they are antihypertensive drugs, or both of them they are antibiotics, no problem. And for example, two drugs, they are same kind. But these two drugs, they have different Ld50. For example, A drugs, the Ld50 is 1 gram is 10 is kilogram to the body. And the B drug, the same kind with A drug, but different Ld50. Ld50 is 1 milligram each kilogram. And compared to A drug and B drug, just now I explained what's the meaning, the significance of Ld50. The greater, the larger is the Ld50, the greater safety of the drug. So from this significance, we can know If we want to use A or B drug to treat hypertension or treat edema, and we use which versions, A drug or B drugs, which one more safety? And we know, we should use A drugs. Why we should use A drugs? Because we have known, just now we explained, the larger the ratio is, the greater the safety is. So in these two drugs, we use A drugs. For example, let's explain. That means A drug, we use 1 gram A drug and lead to 50% animal died. And we use only 1 milligram, also lead to 50% animal died. So compared to A drug, B drug, we use low doses, lead to 50% dead. And A drug, we need large doses to induce animal death. So that means A drug more safety than B drugs. And in clinic, because they are same kind, so we should use A drug. Because A drug, the Ld50 of A drug larger than B drug. That means A drug more safety than B drugs. So the same kind of drug, and we use this one because we can use Ld50 to describe the safety of a drug. And we use Ld50 in clinic to describe the safety, to determine the acute toxicity. So each drug is used in clinic. Before used in clinic, we should observe the Ld50 because Ld50 can describe the safety of a drug. And we use these 4 methods can calculate to test Ld50. This method includes the first method is I measurement probability unit method. The second method is linear regression method. The third method is Carber's method. The last method to test Ld50 is a sequential method. And in them, the easiest, the most widely used method is this one, Carber's method. And today, in this class, we will use Carber's method to calculate the drug's Ld50. We will explain the details of Carber's method, and then we can calculate the Ld50. Okay, so the details of Carber's method. The first step, let's begin the labs. We use Carber's method to assay the 50% lethal dose. The first step is pre-testing. And we should group upper limited dose, Dmax, and group lower limited dose, Dmin. What's the meaning of Dmax and Dmin? The definition of Dmax is the minimal dose which can lead all animals to death. And from this definition, we can know if we use the dose is Dmax, the death rate is 100% because the minimal dose which can lead all animals to death. The second definition is Dmin. What's the meaning Dmin? That means the maximum dose which can lead to no death of the animals. Students, if we use the maximal mean, use these doses, and the death rate is 0%. Because as now explained, the maximal dose which can lead to no death. So the death rate is 0%. From this Dmax and Dmin, in the pretesting, we have obtained these drugs, Dmax and Dmin. In this class, we will observe dipteryx, Dmax and Dmin. We will observe the Ld50% lethal dose of dipteryx. In the pretesting, we have obtained Dmax. Dmax of dipteryx is 10 mg, each 10 gram. That means can lead all animals to death. So if we use 11, 12, or 13, yes, the death rate is 100%. If we use 9, 8, 7, the death rate is reduced. Compared to Dmax, in the pretesting, we have obtained the Dmin. The Dmin of dipteryx equal to 3.3 mg is 10 gram. 3.2, 3.3 mg can lead to no death of the animals. So, from the definition of Dmin, that means if we use 3.4, 3.5, 3.6, and the death rate is increased. And if we use the doses lower than 3.2, and the death rate still 0%. Okay. The first step, just now we have finished. We have grouped the upper limited dose and the lower limited dose. We have grouped the Dmax and the Dmin. In the first step, grouping the upper and the lower limited doses. Upper limited doses, we call this Dmax. And just now we have obtained Dmax is 10 mg. And we also grouped the Dmin. What's the meaning Dmin? Means the maximal doses lead to no death. And we have obtained the Dmin in the pretesting labs. The Dmin of dipteryx is 3.3 mg each 10 gram. So now I have a question. We use later the first group. You should use the dosage is Dmax 10 mg. And in your group, the animal's death rate is 100%. Just now we have explained what's the meaning of Dmax. Means that all animal died 100%. And later, the last group, the sixth group in our lab, you will use the drug's dosage is 3.3. 3.3 mg is the Dmin. We also have know the Dmin. What's the meaning Dmin? No death. So the last groups, the animal's death rate is 0%. 0%. And this class, our aim want to observe Ld50. Do you remember just now we reviewed the definition, the conceptions of Ld50? 50% lethal dose means the dose raised to the death of 50% of subjects is called Ld50. And Ld50 show the death rate is 50%. 50%. And 50%, though we don't know the details of Ld50, we know Ld50, the dose of Ld50 between Dmax and Dmin, between 10 to 3.3, maybe 6.5, 6.7, or 7.2, maybe 5, 4.8, 5.8. We don't know the detail. But in the first step, in the Kovar's method, the first step, we know Ld50 between Dmax and Dmin. Okay. Just now we explained the first step of Kovar's method to calculate to test Ld50 grouping, Dmax and Dmin. We have finished. And next step. Next step, determine the grouping interval, determine numbers of groups, and determine the doses of per group. What's the meaning of the grouping interval? Grouping interval, H is the logarithmic difference. For the doses of two consecutive groups, we call this logarithmic difference is D. And from this definition, and we should know two consecutive groups. That means the second group compared to the first group. The third group compared to the second group. The fourth group compared to the third group. And the fourth group compared to the third group. The fifth group compared to the fourth. And the last group, the sixth group, compared to the fourth group. They are two consecutive groups. And later, each group use different doses, drugs doses. So now we explain the grouping interval again. Grouping interval is the logarithmic difference for the doses of two consecutive groups. We call this is D. In Kovar's method, logarithmic grouping interval D equals log Dmax, and subtract log Dmin, divide group number, subtract 1. Just now we have known log Dmax is 10, so log 10. And Dmin is 3.3. In the first step, we have grouped Dmax and Dmin, upper and lower limited dose. And the group number. Later, we will divide our experiment animals into 6 groups. So we put these values into this equation, and then we know D equal to log 10, subtract log 3.3, divide 6, subtract 1, and then we can calculate D. D equal to 0.096. And we want to use this one, similar to 0.1. So D, the value of D is 0.1. Later, we will use this D value to calculate Ld50. The second step of Kovar's method to calculate Ld50 is determine the grouping interval. 0.1, 0.1. And maybe you feel, oh, teacher, it's very difficult to understand. Yes, it's very difficult to understand. But this lab very easy to do. Later we give the drugs and then we wait 1 hour to calculate the death rate. That's all. And the lab is very easy to do, but the lab very difficult to understand. So we use more time to explain how to do the labs, and you can understand why we do the labs and how to calculate the Ld50. The second step, determine the grouping interval, and we have obtained the grouping interval equal to 0.1. Next step, determine the animal's number of groups. In Kober's method, we should divide the experimental animal into 5 to 8 groups. And in our lab, we divide experimental animal divided into 6 groups. So 6 groups in 5 to 8. So it is suitable to Kober's method, divided into 6 groups. And then the ratio. R is the dose ratio of 2 consecutive groups. What's the meaning? These are the dose ratio of 2 consecutive groups. Just now explained 2 consecutive groups. So later, the dose of the second group compared to the first group, this ratio is the R value. Same with that one, the third group, the dose in the third group compared to the dose in the second group, this ratio is the dose ratio. The fourth group compared to the dose of the third group, the dose ratio. Same with this. So the dose in the fifth group compared to the dose in the fourth group, and this ratio is the dose ratio of 2 consecutive groups. In Kober's method, have the equation. We can calculate the dose of ratio of 2 consecutive groups. R group subtract 1 equal to the mean divided the max. So we can calculate the ratio, dose ratio. Dose ratio, this is group number, 6 groups. Just now we have known subtract 1 and makes the mean. The mean we have obtained in the pretesting 3.3. Divide the max. We also obtained the max. The upper limited dosage is 10. So from this equation, we can calculate R equal to 0.8. 0.8. So this ratio, the dose ratio of 2 consecutive groups is 0.8. Maybe you're confused. Why, teacher, we calculate the dose ratio of 2 consecutive groups in Kober's method? Let's explain. Later, the first group use the Dmax, means that the first group use 10 milligram. So use the drug dosage is 10 milligram. And the second group, we don't have the drug. Need the students, you should dilute the drugs by yourself. How to dilute the drugs? At the ratio of R. the dose ratio of two consecutive groups. Thus now we have calculated 0.8. The ratio is 0.8. So that means the second group, we should dilute the drug at the ratio of 0.8. So that means the second group use the drug's dosage is 8. And then the third group, we don't have the third group's the drug's dosage. And just now we said the dose ratio of two consecutive groups. And at the same ratio, we dilute the drugs. At the same ratio is 0.8. So the second group at the ratio 0.8 dilute the drug. That means the third group use the drug dosage is 6.4 milligram. Same with this method, we use the same ratio to dilute the drugs, and we can obtain the different drug doses in different groups. So the fourth group at the same ratio 0.8 compared to the third group. So 0.4 multiply 0.8, it makes 5.1. Okay. And then the fifth group also at the same ratio to dilute the drugs. That means the fourth group, the dose is 5.1 multiply 0.8. That means the fifth group, the drug's dosage in fifth group is 4.08. Okay, about 4.1. And then the last group, the sixth group, we also use the same ratio, 4.1 multiply at the same ratio 0.8, and we can calculate the make equal to 3.28. Okay, 3.3. Now I think you can understand the covers method. The first group use D max, and the last group use the D mean. And the first group, the death rate is 100%. The last group, the death rate 0%. And the Ld50 between them. And we use the same ratio, at the same ratio, R equal to 0.8 to dilute the drugs. And each group use different doses drugs. Okay. The second step in the Kober's method to test Ld50 is grouping. To determine the group interval, number of group, and to determine the dose ratio of two consecutive groups. And we obtain the different group have different drugs doses. The first group 10 milligram. The second group, the drug's dosage 8. The third group, the drug's dosage 6.4. And the fourth group, later you use the drug's dosage is 5.1. And the fifth group, we use 4.1, the drug's dosage. And the last group, the sixth group, the drug's dosage is 3.3. And later, different groups will give different drugs at different doses. Okay. Next step, preparing different dosage drugs according to low ratio dilution method. Low ratio, just now we have obtained the dose ratio is 0.8. Okay. And D is total drug volume. B is group drug volume. Each group, for example, later we will give each mouse 0.3 milliliter drugs, each 10 gram, and one mouse about 20 to 22 to 25 gram. So one mouse we give 0.8 milliliter drugs, and in each group we use 10 mouse, means each group need 8 milliliter different dosage drugs. And the total drug volume, how to calculate the total drug volume? In Colbert's method, the equation of total drug volume equal to 1 divide 1 subtract R and then multiply B group drug volume. So we put these values into the equation. R just now we have known it is the dose ratio, low ratio. We have calculated R equal to 0.8. And this B is group drug volume. We have obtained it's about 8. Each group need 8 milliliter different dosage drugs. And then we can calculate the volume of the D, total drug volume. So that means in our class, we use 40 milliliter drugs to calculate the Ld50 total volume. So next step, we will prepare the drugs. Just now I have said different group use different dosage drugs. The first group use the first group. Do you remember? You use the Dmax 10 milligram is 10 gram. So the first group, later, the students in the first group come to here and take 40 milliliter drugs as the total volume and take these drugs into a big beaker. And then the students in the first group extract 8 milliliter drugs as your drug solution as the first liquid. And then, just now we know 40 milliliter total volume, and the first group of students extract 8 milliliter. And then that means we only have 32 milliliter drugs. The second group of students come to here, add 8 milliliter water. So this 40 milliliter, add 8 milliliter water, 10 into 40 milliliter. And 10 into 40 milliliter, just now only 32 milliliter drugs, add 8 milliliter water. So that means we dilute the drugs at the ratio of 0.8. And the second group add this 8 milliliter water into the big beaker. beaker means dilute the drugs at the ratio of 0.8. And then the student in the second group extract 8 milliliter drugs from the big beaker as the second liquid. That also means the drugs also turn into from 40 turn into 32. Turn into 32. So the third group of students also add 8 milliliter distilled water into the big beaker and then turn into 40 milliliter. That also means dilute the drugs at the ratio of 0.8. And also extract 8 milliliter drugs from it as the third liquid. As the third liquid, so the drugs also turn into 32. And the students in the fourth group add 8 milliliter distilled water in the big beaker. 32 turn into 40 means the fourth group students dilute the drug at the ratio of 0.8. And then the students in the fourth group also extract 8 milliliter drugs from the big beaker as the fourth liquid. By this method, each group add 8 milliliter water to dilute the drugs at the ratio of 0.8 and then extract 8 milliliter drugs as your group's drugs. So repeated this method. By this method, we get 6 different doses. Okay, we have a video and let's do the prepare the drugs and then we can do the labs. Okay, let's watch the how to dilute the drug and each group of students you can get your different dosage drugs. Okay. How to prepare the drugs?